Okay, welcome everybody. Drake's Lounge, March 2026. And some announcements. The Western Conference Zoom is next Saturday starting at 8 Eastern. I will send out the link. I'm going to send out the link after this, sometime this afternoon. Didn't want to get it confused with the Drake's Lounge link. There is no registration. You just pop in. So members will get everybody that's a member will get the notice. And if you're a non-member, just need to get online, and you pass this to a non-member if they want to join the link. We are looking for anybody that wants to do a observation report, short observation report. We got quite a few openings still left on the Zoom. Right now, it looks like it's just going to go till noon, so about 4 hours. But if we got a couple more observation reports, you guys want to show off some of your stuff. All I'm looking for is that you have some kind of a slide so we can show slides. That's the only limitation on that. Okay. Any other quick announcements? Let's go to Edward.
Hello, hello. Do you hear me?
Yep.
Great. Yeah, I've been quite busy actually recently over the past 2 weeks. I've had two visits I visited the cameras site 2 times. This is Dwingeloo radio telescope in the northeast of the Netherlands. It's a historic radio telescope that was built in 1956, and it was one of the first like large dishes that was specifically built for radio astronomy. So it's quite a historic site. I actually have some slides prepared so I can share my screen if that's okay. All right. Can you see this? Let's put it in presentation mode. Can you see this? Great. All right. So there were actually sort of two main things or events here. Yesterday there was the Hydrogen Line seminar at Cameras and Astron. So this was hosted in the building of Astron, the Netherlands Institute for Radio Astronomy, and it was organized by the organization CAMRAS, which is the organization that maintains the historic radio telescope there. So the seminar was about the hydrogen line in your own backyard, or in Dutch, de waterstoflijn in je achtertuin. And it was mostly talks, but there was also quite a bit of time and room for practical demos. So quite a lot of people brought their own antennas and small dishes. And as you can see here on the right, so there are also some live demos of receiving the hydrogen line with various types of antennas. Anything from helix antennas, you can see here a Yagi antenna over here, and there was even someone who just brought a very simple antenna made from a paint can, literally. So that was yesterday, it was quite a success. There were about 100 visitors, so actually a surprising number of people who are interested in this sort of stuff and are willing to travel all the way to for this event. So last week I was also at the same observatory because I was actually there for a series of observations together with Tamerjan Dijkema and Thomas Telkamp from Cameras. They can actually operate the telescope and they do a lot of astronomical observations with it. And yeah, I was very happy that I could join in once again and do a bunch of observations we did a bunch of observations of OH masers mainly, but also radio recombination lines. So first of all, we re-observed several circumstellar OH masers that we have observed before, but we also observed a couple of new ones that we haven't seen before. We did a number of observations of some star-forming regions, and the neat thing is that Thomas was using an Atlas B210 SDR, and he was using the two different channels of this SDR at two different frequency bands. So we could simultaneously observe at 1420 to 1425 megahertz and 1665 to 1667 megahertz. So we could see both the hydrogen line and the H166 alpha radio recombination line and the two OH main lines at the same time. So I'll show these observations in a minute. And to finish things off, at the end of the day, we also did an observation of a radio recombination line at S-band in Orion A. I'll also get to that in a minute. So for calibration of the OH maser observations, we attempted to do on-off measurements of the Cygnus A continuum source, which has a well-known flux density, so we could use that as a sort of calibrator. But yeah, so far I don't really know how accurate my calibrations are at this moment. I'm still processing the data. So this was me at the telescope, as you can see. Here this cabin under the telescope, that's also where the control room is. And it actually rotates with the telescope. So if the telescope is rotating, the control room is moving as well. It's quite fun actually to be in there when it's moving. So this is the inside. A lot of equipment, but most of this equipment is just historical and it's no longer really in use. So this is the view from the inside of the control room. And these were some observations of some OHIR stars at 1612 megahertz that we haven't observed before. Yeah, I still have to check whether these peaks match up with what's known about these masers on, for example, the maser database, MaserDB. I still have to check, so it's still quite fresh data. And we also observed this one. So this was our Aquila. This is actually quite an interesting OHIR star because it's one of the few that you can actually see with a simple visible light telescope. So most OHIR stars, these are red giants that have a lot of mass loss. So they're losing their outer atmosphere into space. And this creates a very dusty shell around the star. And this dusty shell also contains this OH gas, which forms these masers. But due to all of this dust and gas, usually we cannot see the stars in the optical. They are only visible in infrared and in radio. And our Aquila is one of the rare cases where we can actually see the star itself in visible light as well. So I thought this was an interesting one. Also, one thing that would be interesting as more like long-term project is to monitor the changes in brightness of this source over time and check it against the variability of the star as it's known, for example, from the AAVSO, a variable star database. So because it's actually a star that is visible in visible light, there are observations of it. But obviously that would take a lot of time and a lot of observations. And unfortunately, I can't be all the way up in Dwingeloo all that often because it's quite far from my home. Anyway, so this was some observations of Westerhout 49. As you can see here are the four spectral lines that we were observing at the same time. So of course the hydrogen line H106, then H166 alpha at 1424.7 megahertz, which is a radio recombination line. Then of course the OH lines at 1665 and 1667 megahertz. So you can see here that the radio recombination line was not really detected, but we also only did about 5 minutes of integration time on this source, and radio recombination lines are typically quite weak, so this is not really a surprise that we really didn't detect anything there. The OH masers, on the other hand, they are quite strong. So both the 1665 and the 1667 megahertz line are quite strong in this source. So Westerhout 51 was actually quite an interesting one. So maybe we detected the H166 alpha radio recombination line, but it's very broad and yeah, maybe it's also partially just the bandpass from the receiver that we are seeing here that's not fully subtracted out. So there was some emission at the 1665 megahertz line, and interestingly, instead of emission, there were two very prominent absorption features in the spectrum at 1667 megahertz. So we haven't really seen something like this before, so this was quite interesting. So this was another star forming region, Westerhout 75 up in Cygnus. So again, there's an OH maser there, but there's also some weak absorption features possibly at 1667 megahertz, although not nearly as prominent as what we saw at Westerhout 51. So Westerhout 3 is also another classical star forming region And this was actually a very bright maser at 1665 megahertz. It was also detected at 1667 megahertz, but as you can see, it's much weaker at that frequency. The radio recombination line was maybe detected as well, but as you can see, it's quite weak. Also note, of course, that the vertical scale for the radio recombination line is much smaller than for the hydrogen line. And furthermore, you can see here that this just says power uncalibrated. That's because normally what you would do for the hydrogen line is, of course, to express it in units of brightness temperature. But for that, ideally, we would first do a measurement of, for example, the S7 region, so sort of the standard region for the hydrogen line, and then use that to calibrate the hydrogen line measurements. So finally, there was this S-band hydrogen radio recombination line. So this was an experiment that Thomas really wanted to do because at the moment there is an S-band feed in the focus box of the Dwingeloo telescope for receiving the Artemis mission. And this was a very good opportunity to do some radio astronomy at S-band as well. So with about half an hour of integration time, we managed to detect the H142 alpha radio recombination line, as you can see over here. Anyway, that was it. Are there any questions?
I have questions. First of all, thank you for telling us about this. Sounds very interesting. I'm just curious, how long does it, or how far is it from your home? Do you drive or do you take the train up that way, or how do you get there?
It's about 150 kilometers. So usually what I do is that I take the train from where I live to, which is close to where Thomas lives, and then Thomas and I drive together all the way up to the telescope.
And is the telescope in an area that's sort of remote where it doesn't have a lot of RFI or?
So for Dutch standards, it's remote. Of course, like it's not that remote. There's still like villages around, and there's like a sort of like a
So you have Wi-Fi and things like that still.
yeah. There's also the building of the Astron. So the Netherlands Institute of Radio Astronomy is right next to it. So we get some RFI from that as well. So it's not super remote, but it is still like within the radio quiet zone of the Westerbork Observatory, which is a radio observatory that's still operational to this day.
And when you go there, do you stay overnight or do you camp out or is there accommodations close by?
There are some bed and breakfasts in the nearby village, and there is a camping nearby. Although I haven't stayed overnight up till now. So usually when I go there, I just go there in the morning and then in the evening I come back.
Okay, interesting.
Okay, Edward, is some big problem to do more long integration time? I saw 5 minutes. Is some problem for longer integration time, 20 minutes or 30 minutes, maybe?
Well, not really. I mean, like in principle, we could do like 2 hours if we really wanted to. But the thing is that when we go there, it's not so often that we have the time to observe there. Usually, we have like multiple targets that we want to check for that day. So we kind of try to reserve like the longer integration time for like some interesting things that we really want to do. For example, for this radio recombination line in the Orion Nebula at S-band, because well this was the time when we had an S-band feed available in the focus of the dish. So we really wanted to do at least that experiment. And for Westerhout 49, we have observed this source before and it's quite strong. So for us, it was not really like worth the effort to put a lot of integration time in that.
Okay, thank you. It's great observation of higher in frequency radio recombination line. Thank you.
Thanks. Yeah. So I don't know if Tamujan and Thomas are watching this afterwards, but if they are, then I would like to thank them for once again giving me the opportunity to join in on this observation session. It was a lot of fun. Anyway, any more questions?
All right. Thank you very much. Good work. Okay, Dmitri's back. Let's try this again. Go ahead, Dmitri.
Okay, thank you. I think sorry, my first attempt was interrupted by connection problems. I will continue. Do you see the screen? Do you see the screen?
Yes.
Okay. Okay, thank you. Thank you. I'm continuing my talk 2 weeks ago about radio recombination line H166 alpha observations from central of the galaxy Sagittarius A region. This region contains supermassive black hole, Sagittarius I star, 4 million solar masses, and traces of its recent activity was also seen in Fermi bubbles in 21 centimeter of neutral hydrogen. This is recombination line 1420, about 1425 megahertz, close to H1 frequency, size of spot about 1 degrees in radio recombination line. And now I will present H1 results from the same observations and consider that 1 degrees of whites also can be applied for spot of H1 and H166 alpha spot. This region is rich of O and B type stars. They are ionized hydrogen, so we can see also besides H1 also radio recombination lines. 20 to 20 meter dish in green bank. Instrumentation system temperature I estimated by myself, not from Skynet data about self calibrations, built-in self calibrations. And the galaxy background in the galaxy center can be polarized, but this polarization is not confirmed in H1 observation. I will see a bit later about results of observations in radio recombination line about minus 20 kilometer per second line and about 30 line width, but two different results in two polarizations. In X and Y polarizations result almost 2 times in level, 2 times of difference in levels. The emissions in this line was originally expected as unpolarized integrations about 200 seconds. And results of observations, H1 results. This is the same set of data because bandwidth of receivers covers also H1 frequency. I consider the same size of H1 spots to obtain brightness temperature. Velocity and waves of highest peak is almost the same as previously detected radio recombination line. For check, you can see almost the same plot from lab survey. Thanks for Edward. This picture is copied from him. You can see also if you want H1 spectrum, you can go this address and to get a spectrum from other point of the sky. Levels of lab survey almost the same as I obtained from my post processing, about 17 Kelvin in brightness in peak levels. This is almost the same level, so it means the calibrations telescope characteristics from my calculations is more correct than system temperature from self calibration in Skynet. But in both polarizations levels almost the same. It means that background polarizations, almost no background polarizations, and sensitivity of telescope is almost the same in both polarizations. And so the difference in polarizations of rational line cannot be explained by background polarizations and errors in polarization in calibration of telescope. So this is some questions, but this is here some questions, some puzzle, because emission polarization of in recombination line is not expected, and for now this difference in polarization is unexplained now. This is all for now. If some questions, I will be glad.
All right, any questions for Dmitri? This stuff's recombination stuff. You guys are really doing good on this. So thanks a lot.
Okay, thank you.
Okay, let's see. Anybody else not in the US that's online? Okay, I'm just going to go down the list. Ted.
Hi, everybody. I'm celebrating St. Patrick's Day coming up. This is the closest I had. Do I have any news on radio astronomy? Not particularly. I've been doing optical meteor cameras and finally getting that going. I keep coming up with new ideas for Ezra, and I got to finally publish them and post them for everybody. Nothing after that. Back to you. That was it, Rich.
Okay, thanks. Tom, how you doing?
Well, I'm here and I'm doing a little bit more typing, but I'm still basically a one-handed typer. Maybe I'm back up to 7 fingers now, but just trying to survive.
Okay. All right, thanks, Tom. Rick.
Oh, we haven't done any astronomy at DSES in a few weeks because we're working on the manned spaceflight mission, Artemis II, and that's what I'm working on this morning. And I'm also working on a proposal for the Venus-Earth bounce phase 2 project. So I'm hoping to get back to pulsars, magnetars, and drift scan work soon after the manned spaceflight mission is over.
Okay, thanks. I think I need some of you DSES engineers to go down to NASA and fix the Artemis II.
Well, I'm a little worried about it now because I read that they're going to roll it back out in the next day or so, but that they're not going to do another wet test. And I think that's a personal preference. That's a big mistake.
I'm not sure I'd want to be an astronaut on that flight.
No, not unless it passes a wet test. Artemis 1 never passed its wet test. They launched it anyway. And Artemis 2 has failed twice now. I'd rather that they do another test personally, but if they don't, we'll be out there in April tracking the mission from the SES.
So do you have all your equipment working like you wanted to now?
No, it's never working like we want it to. Every time we test it, we find areas where we can make improvements. And the guys were out there this weekend testing the feed using a beacon about 8 miles away to confirm the steering of the dish and the performance of the feed. And they were not satisfied, but we're going to make a couple of modifications to the feed and test it again before April. We'll see. It turns out because we're looking at a hot signal, if we're off by a few dB, it won't matter. We'll still track it okay, but we want to do the best job we can.
Well, is this a matter of you're getting a signal that you can report with, but you're just not getting the resolution that you'd like to have?
I think we had a failure on our 16-bit elevation sensor that has been fixed. So steering is always, we have to be very careful because at these frequencies, our beam width is 1/2 degree, so our steering has to be pretty good. We think we got that under control now, but we were not satisfied with the signal strength that we received from the beacon at 8 miles distance, where we've tested that same beacon on other feeds on somewhat different frequencies with much better results. So there were some concerns that something might be wrong with our feed or with the beacon for that matter, but we're sorting that out now.
And is there a chance to have a Zoom call from that dish during the time y'all are actually collecting data and reporting?
There's been a lot of debate over whether we want to do that or not. There's some people who think they don't want to be photographed in real time, and others who's like myself who think that we should definitely do that. I don't know what's actually going to happen on that front.
Well, failure is sad, but on the other hand, you learn from failure. So if it doesn't work, it doesn't work. But it'd be nice to be able to see it and see what you're doing.
Yes, I agree. I'm hoping that we can have a live feed, but I really don't know. That's not my area.
Okay.
All right. Well, thanks, Rick. Keep up the good work.
Thank you.
And Don.
Hello, everybody. Nothing really new here. Been chasing these small drives, the antenna drives, recently, and it's a mess. There's one small drive that's going to be available, but I'm not sure. A lot of these things seem to be driven by stepping motors, and there are a couple of very bad flaws in single drive. In other words, there's no sensors to report the antenna position back. So if you skip a beat or if the load suddenly gets on it and it misses a couple pulses, it's going to report the wrong angle. So I'm not too sure that these things are going to be satisfactory, but that's old curmudgeonry. So we'll keep chasing it.
So Don, remind everybody what's the drive you're talking about?
Well, there's, excuse me, there are a couple of them which are ANT drives. One has been on Tindy, and now there's a couple on Ali, one of the AliExpress. And they're supposed to be able to drive the Explorer dishes, the little dishes. There's some question about the load appears to be satisfactory, 10 kilograms, which, 20 pounds, that's way above the actual weight of the antenna. But there's actually some question about how much torque. Nobody will specify any torque on these antenna drives. And there's a new one coming up for the Discovery by Kraken. We'll see if it seems to be a copy of the ANT drives. I have questions about it. First of all, when you're driving stepping motors, you get terrible spikes on everything, power supplies and all kinds of things. And they're very steep. The reason they're steep is because they're efficient. And the MOSFETs switch rapidly and cause spikes in everything, on your power supply lines, on your bad grounds, on just anything that can pick them up. So I have questions about that. Second, they want to do them on Wi-Fi, which is, of course, the 2.4 gigahertz for most of it, and not even 5.7. And to me, you're just asking for it. And people say, well, it's way above the frequency that you're looking at. Sure it is, but the problem is it's modulated. And so you're going to have noise from the modulation. It's the same thing with USB. You have to wrap it in some toroids, and you have to be very careful about what you're doing there too, because you can drive yourself crazy with your own RFI just trying to get the dish pointed to where you can see something. So I really think the community needs to be aware of these things. I hate to be curmudgeonly about it. I mean, they decide to use the ESP series of little computers because they're cheaper and they have Wi-Fi. But I don't think Wi-Fi is the right thing to do. I think you're much better off driving it with something like Modbus or some much lower frequency stuff that you can control quite nicely because there's no spikes involved. So I don't know. We'll see
I'm
how
full
it
of
goes.
I'm full of questions today. You once mentioned this thing called a RoboClaw, which I have one of them here. You
Good, yeah.
using that? Are you working with that still, or?
No, but I have something similar. It's the same thing. It's still a drive, which is all of them are using switching MOSFETs. And even worse, you drive it with a switching power supply. You're just asking for trouble. On the other hand, my motor drives on the dish you see behind me are 12-volt motors with the brushes, and they're not even magnetic, motors, but the problem is the drivers. All of these switching drivers are switching at like 15 kilohertz, and they're putting out pulses of incredible strength. So you need low pass filters on the motors and things like that. And I'm just not sure about it. Let's put it that way. I haven't done enough experimentation. I'm being dog in the manger, or whatever you might call it, curmudgeonly about it, and imagining everything that can happen. It's a bit theocratic, actually. But the thing is, those problems are there. And I do think just compounding the problem, you drive a switching regulator with Wi-Fi, and you use a switching power supply to drive the whole thing. Holy mackerel.
Don, when you say that
Yeah, Wendy.
all of the switching motors are like that, are you including yours in the all?
Yes, I am. I have to try to figure out how to curb this business of switching it in the neighborhood of
This rampant switching.
well, the switching is because you're using pulse width modulation, Wendy, and the way you generate variable voltage with pulse width modulation is you drive everything into sort of into, depending on the motor, acting as a low pass filter. And so it sees DC, sees direct current, because you drive it into a capacitor. But the pulses are still there. They're on the power supply because you're switching energy. Every time you switch energy with a fast pulse, you make noise, lots of noise. And a pulse makes noise in a broad spectrum. So it's a real problem. Now,
Well, you could do things like have it move to a slew to a place and stop and settle
yes,
for a second, then
yes,
collect your data and then go to the next place. Then you only have to fight the power supply problem. And there you could have a secondary supply that's got more regulation, that's a linear
yes,
regulator, and try to
yep,
quieten that all down. And you have to box everything up. So I'd suggest you just move forward and
that's
see what you can get
that's
going.
right. Yeah, I have to. Now the snow is beginning to melt off, and maybe I can get back to it. But yeah, the reason that I like the RoboClaws is because they have a lot of driving software that goes along with. and you can drive them with programs that are already written, more or less, and the protocols are there, and you can read. They include reading an optical encoder, so that you can actually read. If you put the encoder on your antenna, you can actually read where your antenna is pointing. And that's just absolutely necessary, in my opinion. I don't think the single mode drives, whatever they're called, where you're driving a stepping motor that's geared down and you're counting steps to tell you where you're pointed. First thing is you have to start it out at a known angle somehow. When you turn the power on, lately I've been using or looking at and playing with absolute encoders from our dear old AliExpress. You can get 16 bits absolute with Modbus, which is a protocol for driving, which is apparently old and well established, and uses RS-485, which is a sort of a thing of RS-432 or whatever it is. So those encoders are relative, especially for less than 16 bits. So they're quite inexpensive. They're well built, as far as I can tell, and they have ball bearing shafts. They're 6mm shafts, unfortunately, but they're adapters to 1/4 inch if that's what you need. And they work quite well. So I don't know. I'm running off the end of the pallet here, but
it's okay. Don, let's
it's time
go
to go ahead.
offline on the rest of this conversation and get the rest of these guys. Good information, though. That's great stuff.
I hope so.
All right, thanks. Adrian.
Yes. Hi, everyone. Well, let's see. I've been dealing with kind of misfortune of a lot of computer problems. I've had laptop crashes that just completely put me under. And this has been kind of a continuing problem with me. I've just had a previous laptop that crashed a while back, and this is the computer I'm on now, and just barely have got it back up running, reinstall operating system, replace the SSD drive on it. Yeah, these new drives are fantastic. They're real fast and quick, but boy, if anything goes wrong, they get scrambled so easily. And then you just get that good old Microsoft BSOD, if everyone's familiar with those, and you've got no computer. So I've been dealing with one of those that just happened about a week ago. And like I said, just barely got this laptop now running. So hopefully I'll be able to get things back in order and try to continue with trying to get set up for some radio astronomy. So anyway, that's the history of my woes.
Okay.
So until next time, thanks.
Thanks, Adrian. Conrad.
Hi. Well, the big news for us, or for me, is that our 3 feet of snow is finally melted. It's gone. And so now I can get back and do things. I am making a modification to my scope in a box. Thanks to Alex Pettit, he sent me some information that he's used with his scope in a box or his antenna, how he's added some aluminum screening to it to reduce some of the noise around it. So right now, I'm not gathering any data. I'm in the process of making that modification to it. I'll probably work on that tomorrow because it's going to be a rainy day. And as soon as I get that fixed, I'm looking forward to getting back out there and start a whole new survey of of our galaxy again at all different angles. Once the weather gets better, I'm looking forward to that and comparing this new picture of the galaxy with the one that I have behind me that I started with just the raw scope in the box. And as soon as I get that done, I'll let you know about my results. I'll be glad to put on a little presentation.
I think you're following the standard. Once you get the basics done, then you just need a bigger and better telescope.
Oh, that's always true in optical astronomy. As soon as you get one kind of a telescope, okay, it's just a matter of time before you want a bigger one and a bigger one, and then you do something else.
Right, right. Okay. Thanks, Conrad. Good work. Dennis Hufnagel.
Okay. Hey, Rich, good to see you back at the helm. That's not to say Ted didn't do a great job.
Oh, Ted does a wonderful job. I can't wait for him to do it more often.
I see. Anyway, I have nothing to add here. I'm really enjoying all the input. And I always enjoy Ted Conrad talking about his work with his scope in the box. Mine is not even to the point of worrying about interference coming in around it yet. But I agree, with optical, I can't believe my little hideaway is filled with so many scopes. I really should get rid of them before my wife has to find a way when I disappear. But it's always onward and upward, bigger and better. Thanks.
I saw a meme, and it was based on a gun collector. He says, I sure hope when I die, my wife doesn't sell the guns for what I told her I bought them for. So, yeah, totally losing money at that point. Yeah, Preston.
Oh, you caught me eating jelly beans, but no, I don't have anything to add today.
All right, thanks. Ed Harfman.
Nothing today.
Okay, thanks, Ed. Wendy.
Nothing today, thank you.
Okay, Carl.
Hi, afternoon, Rich and everybody. It's afternoon here. A couple of things with my teaching work. We are currently in my class, we're building the structure for the SuperSID detector, PVC pipes and all that. And I had a question for the members, perhaps. I mean, everybody here's got a lot more expertise on this. As we thought of started to do the winding for the coil, we realized that we didn't have the 400 feet of 20 gauge wire that we expected. So we're at this crossroads of, is it a problem splicing the wires together to get the length that we need? I just don't know if that's an issue with the SuperSID. If anybody out there has experienced this, or just in general with these coiled antennas, does that create a problem? That's the one thing we have. And I guess our further plans are to get the scope in the box done by the end of the school year. So that's kind of the plans that we have, but we're a little bit held up right now with some technical issues with the SuperSID. So that's kind of what I have out there right now.
I had a SuperSID for 5 years. It's currently, the wind destroyed it this summer, or this winter. No, it shouldn't matter. I'll just, if you add another length on there, just to insulate the where you added it, and then you should be fine.
Okay, great. That should help out. And thanks again for having the group like this, keeping this group together, because it's motivating for my students to see that there's all this expertise out there that they can rely on. So I really appreciate that, all the work that everybody does with all these really cool projects that we get to take a look at. So.
Well, here's an offer, Carl. If you want to have your students do a small observation report, then we can publish that in the journal, and then that can motivate them to be a published science person. We could do that for a number of your students or all of them. And if you want to do something like that, or we can have a special session where we do a Zoom call with them presenting, and then they could be on YouTube.
Cool. That's the report, definitely. That's something we can definitely put together, because we've always got a number of science competitions and they're looking for student submissions. So this, that could be one that'll definitely try to get together before the end of the year, the journal submission. Yep. And then the Zoom,
Sure.
definitely think about, doing some sort of a Zoom activity. With school, sometimes with Zoom and having kids on the internet, it's an issue to have, their faces and things.
Oh, good point. Good point.
Yeah, the journal submission, that's something we can definitely look at because we'll have collected some data with at least the SuperSID and hopefully the scope in the box before the end of the year. Just in addition to that, I did take your advice and we had signed up for access time on the 20-meter dish in Greenbank. So that's in the works. Also, hopefully we can get to utilize that as well. So it's a really great resource that we have for for students in high schools. So thanks again for that.
Oh, excellent. Excellent. Yeah, that'd be good.
Yeah. So
right.
That's all I've got for today.
Thanks, Carl. Good work. Pablo.
Really nothing to add. I'm looking into getting the German equatorial for $300 to mount the Discovery dish, and in a German equatorial fashion. And I'm looking at Losmandy AZ8 Aldaz mount head, which is about $1,100, but that has the capability of driving 35 pounds. And then I don't know how I would waterproof that, but basically that's all I'm doing right now.
Okay, thanks. Bob.
Okay, I was full of questions today. I'm sorry I keep asking questions, but I'm working away on this little preamp board that I've been working on, and I've got it working. What I chose to do in the design was to put the filter in front of the LNA. And when you do that, you add the loss of the filter to the noise, so it's got about 2 dB of noise. And so I've decided that's too much, and I'm doing another design that I'm gonna have. So I'm gonna have both options. Now, if a person lives in an area that has a lot of RFI, then he would want to use the one with the filter in front of it and give up that initial loss. But if you didn't and you really wanted to get the most sensitivity out of it, then you'd want the filter after the LNA. And so I'm going to have both possibilities here. And the filter has about 2 dB of loss, so that's the penalty for having the filter in the front. This is a fairly wide filter, but it's inexpensive. And if you get the filter very narrow, then it goes up 4 or 5 times in cost. And that's all possible. But I have that thing working now. I've done a second spin of boards and proven those out. And the board that's for the RF device, to get the best noise figure, I feel like I need to use a special material, and I just hadn't released that yet to get PC boards made. I have other projects going too at the same time. Like I have this little 1-meter dish that has motor drives on it, and it's sort of like on the same path that Don was on. It's got stepper encoders from US Digital, and it does indexing where it rotates back. And it's a pretty reliable thing because it was originally designed to be used in oil equipment in the deserts and things. And I got it given to me, so I think it'll work out okay. I've had to redesign the control system on it because it's all proprietary and I didn't have all the information, so I had to put my own control system. So that's where I'm going to use this Robo Claw to move it around. That's my plan right now. And then I have this bigger dish. It's a 5-meter dish that I never have put in play that needs a pretty humongous drive. It's a solid spun aluminum dish. And I hear you talking, Pablo, about this 1100 drive. I found it's going to be about $2,000. I have to requote it because with all the things that have happened in the marketplace, I'm not sure where the price is, but it's around 2,000 that'll move a really heavy load. So I think you could get a pretty precision 2-stage encoder or 2-axis controller for a dish for a lot less than that. That if you only want to move 35 pounds, I'll try to find the information and post that for you so you can consider that as an option too.
Well, I just ordered the $300 one just now because I have 4 of those, and I can always use it for another telescope.
That sounds more reasonable anyway. That 1100 sounded like a lot, but for only 35 pounds. But precision, I guess, is important to you too if you get it aimed.
The one that I just ordered has an ASCOM capability, so I can use radio eyes to drive it, no problems.
Yeah.
And I can attach a guide scope with an ASI 120 camera on the side to synchronize the mount perfectly at night, and then have it mounted and synchronized during the day 24/7.
Yeah,
And
I think
for
that's a good approach myself. I use that approach for those types of things with my meteor cameras, and you can get good data and align things very accurately by using the stars, the old
right,
sailor's method. But
that's
the other thing I was going to mention was on the encoders. I've got some Austria Microsystems or AMS encoders that are magnetic encoders, and you essentially put a magnet at the end of a shaft, and then you put this encoder right up next to the end of that shaft and that magnet. And I've made 3D plastic parts to do that, and you can get some pretty high resolution. And these things are made for automotive applications, so they're pretty robust and reliable. So it's an alternate way to get absolute encoder position information as a possibility for these dishes too. And I should expand on that later too. Anyway, that's all I have.
A quick question.
Yes, ma'am.
The printed circuit board assembly you've designed, you said it has 2 dB loss if your filter's in the front. How
Yeah.
much loss does it have when your filter's on the other side? Just out of curiosity.
Okay, then it really ends up being the noise figure, Wendy, and the noise figure is of the device itself is about 0.3 dB. And so with the filter in front of it, it's got a 2 dB loss, so it ends up giving you a noise figure of 2.3 dB. Now, I also have another zero point 0.4 to 0.5 dB of loss due to a pin diode switch, which is like a relay or just a switch that goes between a 50 ohm resistor and the LNA. And so I won't eliminate that. So the net result with moving the filter would be that let's call it a half a dB loss of the switch plus the LNA's noise figure. So I'll have about 0.8 dB. That's a whole lot more than Wolfgang's amplifier that he's real proud of, that you can't even measure the noise figure, but it's not that bad for one that's more readily commercially available, I would say.
So are you going to, after you get through with it, you going to publish your schematics and so forth?
Yes, and what I was going to do is I'm using like 0402 components that are very small, and a lot of people would have a hard time soldering those. So I was going to probably have the folks in China build these boards up with those smaller components. I found that they have inventory on all the parts that are needed except the filter, and then that filter could be added by a person. That's my current thinking right now. So the opportunity would be to buy a board with all the parts on it but the filter, and then buy the filter from somebody like Mauser and solder that on later. That's my thinking right now anyway.
Quick question, Bob. This is Adrian. Are you planning on building these on Teflon, or are you still sticking with RF?
It'll be a Teflon material. It's like a 2 or 3 board stack, okay? And one of the boards will be on FR4, which is a power regulator to get the noise down as low as possible from the supply, and also provide the control to make the pin diode switch when you change your supply voltage between like 6 volts to 6.5 volts. That's when it'll switch. And also initially I was fixing it so that the power would come down the same RF line that's getting the signal, but I think that's a bad idea from listening to people here. I've been pretty much convinced that we should push that off to the side and feed the power off independently so that we're not adding any switching supply noise or other kinds of noise to the potential signal. So I'm going to have a provision to connect your supply line to the side of this box that has the parts in it. And I was going to use square tubing, aluminum square tubing that's about 1 inch square,
to put the stuff in. I said that there was 3 boards. There's a center board that's nothing but like a ground plane to shield the control and the power supply board from the RF board.
I see. Well, listen, I really think that's fantastic that you're designing and building this and getting away from the just the off the market, just every, all the equipment is pretty much, off essentially stores and stuff like that. And the home built sort of knack of doing things just kind of seems to have disappeared. And it's just more assembly of purchasing stuff and splicing it together and designing own equipment. I think it's fantastic that anybody's trying it nowadays, since everybody's just always so proud of the latest gadget from the big houses that make equipment or supplies. So I think it's great that you're designing this. So anyway, best of luck, and yeah, thanks.
Okay.
Okay, any more questions for Bob? All right, now I got a JSODE.
That would be me.
All right.
This is my first time listening in to you guys. I've been interested in radio astronomy for a while and have really enjoyed it so far.
Great. What's your name? Where's your location? And do you have any radio astronomy projects going at this point?
The name is actually John. Last name is pronounced Sodi.
Okay.
I'm in Southwest Missouri, and I'm hoping to put a Radio Joe satellite on sometime this spring. It needs to move from its box to the antenna mast.
All right. Okay, well, good luck.
Thank you.
All right. And Wolfgang.
Yes, hello everybody. I have been doing some work with our 10-meter dish recently. Every now and then I've told what the purpose of that dish is, like mainly observing masers. But this time we were doing some continuum observations, and I just want to share some slides, if I may. So let me try to start that. Looks like I don't get it a full screen, but we can work it this way if you don't mind. All right, so what we did were to do some Ku band and Ka band transit scans. We used our 10-meter dish. And essentially the reason why we did this is, first of all, just being sort of reconfirming which sources we can observe. We did that quite some time ago, quite long some time ago, so we're looking into that again. Another motivation is we want to check our pointing accuracy. So we want to see what corrections do we need to apply in our pointing. We also wanted to check the beam width again to see whether that's okay. And the other purpose is that we want to explore whether we can use these sources for calibration of methanol and water maser sources, because so far we don't have any calibration. We can only compare it, and we would rather have absolute numbers. And for that, we need to have calibration sources, and we're just looking into whether these can be used. The sources we have observed so far was the Crab Nebula, which for us in U and Ka band is the strongest, followed by the Orion Nebula, then Cassiopeia A and Cygnus A. You will notice that typically when you look in L band, that Cassiopeia and Cygnus are the strongest, but that turns around when you go to higher frequencies. And also that's actually brand new because it's from today we observe Jupiter. And I just want to quickly show you the transit scans. We haven't done too much of evaluation yet. We're just collecting data at the moment. But this is actually the transit scan of the Crab Nebula. As you can see, it is the x-axis is in right ascension, so you're expecting the peak to be at the right ascension of the Crab Nebula, which is actually the case, with a very small difference, which is a pointing error, which we are looking into. This scan was done at a frequency of 11.2 gigahertz, and we were using 8 megahertz of bandwidth. One of the issues with these scans is the problem of background fluctuations. You have a very strong variation in the baseline, and that is due to clouds. So if you have a clear day, that's fine, but as soon as you get some clouds, the baseline is going up and very dramatically. That shows that it's a completely different behavior compared to L band, where you essentially don't care about clouds and stuff like that. Okay, second is an example, again, from the Crab Nebula, but this is at almost 22 gigahertz, so in Ka band. Same with 8 megahertz of bandwidth. It's much noisier. We still need to figure out from that data how much of a difference we have in sensitivity at Ku and Ka band. We need to look into the data of the sources, but this is just a preliminary data, so we didn't go into much evaluation there. So you can see some of the sources in Ka band as well. And actually, this is the strongest source at that frequency range, the Crab Nebula in Ku band. If you go to the other extreme, the lowest, this is the Jupiter. And I'm showing here 4 transit scans because we weren't sure in the beginning whether actually Jupiter. So we had to repeat that and make sure that we're actually seeing what we want to see. And as you can see, the peak appears always at the same right ascension, which is the right ascension of the Jupiter. So that's this confirms that is actually the planet Jupiter. That's actually all I want to show today, and there will be a lot of more data taken and more evaluation. There's only some preliminary evaluation that we did on some of the scans. That's the beam width. It's as expected. At Ka band, we have about 0.11 degree of the 3 dB beam width, and the Ku band is around 0.2. Slightly over 0.2 degrees. So that also shows that we have to be very accurate with our pointing, and that's why we're making all these measurements to see where we stand in the pointing. So I guess that's all very quickly about what we're doing right now with our 10-meter dish, essentially doing some evaluation and calibration work. All right, thanks. And if there are any questions, I'm happy to go into that.
I had a quick question. This is Adrian. What type of LNA were you using for the 21 gigahertz observations?
Well, that's a commercial LNB, which is actually a dual frequency LNB. It's working both at Ka and Ku band. It's a dual device, which unfortunately is no longer available. I'm trying too hard to find it somewhere again, because if that one fails, we're out of business. And it's modified. One of the problems with the commercial LNBs is frequency stability and accuracy. On the Ku band, this device uses a PLL for the local oscillator. So that's fairly straightforward. Instead of the PLL, which runs, I think, at 25 megahertz, we can inject a 25 megahertz signal from our infrastructure. So that's straightforward. On the Ka band, that device uses a resonator, which is the common practice there, and that runs at around 10 gigahertz, and then its frequency doubled internally. And in order to get that frequency stable and accurate, what we have done, we use a roughly 3 gigahertz PLL, and that is frequency tripled, which gives us the 10 gigahertz signal, which is then fed into the LNB. So that's roughly the setup.
Yeah, great. Yeah, that's my concern at the Ka band is that pretty much the commercial LNBs that are available are the ceramic resonators, and so that's the frequency stability is pretty lousy. There might be some available that are PLL, but boy, the price range on those is still pretty steep. But yeah, that would be the way to do it. Would be to just externally inject the local oscillator from a better stability PLL and so forth.
Yeah.
Great, fantastic. Well, those are really neat observations. Thank you very much, Wolfgang. Thank you.
You're welcome.
Yeah, I also wanted to ask something. But first, I can also comment on the stability issues with these commercially available Ka band LNBs, because I also have one at home. So what I've done is that I'm, instead of injecting generating and injecting an external LO signal, which is quite complicated and requires quite a bit of equipment, I just generate a very faint pilot tone at 22.2 gigahertz that I record alongside with my observations. Then afterwards, I correct for the frequency drifting. So that's another way to deal with it. And I was also wondering, Wolfgang, when you're doing these observations with such a small beam width, like, aren't you starting to like resolve, especially like the Orion Nebula, Orion A?
Yeah, we are actually at the limit for Orion A. I quickly looked it up, and it seems that in our Ka band, our beam width is slightly smaller than the Orion Nebula. Although I have to say, the data that I found so far, and I only did a very quick and dirty research, was for a different frequency range. I think that was for L band, and I'm really starting things on this. I need to find reliable data on the size of the Orion Nebula in Ka band, and Ku of course as well. Yeah, but your comment is correct. We need to be careful that, especially when we go for calibrations, that we are really know what we are having in our beam. The other, as far as calibration is concerned, the other difficulty is the data that I found so far on the flux densities is pretty old. It's from the 1960s. And especially for the supernova remnants like the Crab Nebula and the Orion Nebula as well, we have to see how they have changed. So that's one of the researches. I do know that the bigger telescopes, that they sometimes use Jupiter for calibration, but I really need to look into that details there. So it's pretty much the beginning of an investigation, essentially with the aim to get more reliable flux data for our MESA observations.
Yeah, that would be great. Yeah, unfortunately, like for my 1 meter dish, like these sources will be out of reach. So would it be possible to use the sun or the moon maybe as a calibrator instead, or is that just too unreliable?
Well, the sun is very variable, as you know. The moon, our beam width is much, much smaller than the moon. So I'm not sure what data we can use and how variable that is.
Yeah, okay, for your large dish with a tiny beam width, then you're basically seeing a tiny portion of the moon. But in my case, like with a 1 degree beam width, like the moon would still be fully within the beam. So
yeah,
maybe that would be more useful for a small dish where you don't have access to these continuum sources otherwise.
Yeah, it's what you could with a small dish is actually, if we are feeling comfortable with our calibration, what we could do, make a concurrent measurement of a MESA, and then we can give you calibration data for that MESA. That would be one possibility. But in order to do that, we really need to feel comfortable with what we are doing.
You've only just begun.
Yeah, we've just started that work.
I'm sorry, Edward, go ahead.
No, I was finished. This was my last question. So.
Oh, okay. I just have a real quick question, Wolfgang. On these continuum observations, are you expecting to see any polarization type of effects?
Probably not for the sources that we're looking at. I expect they will be unpolarized, but we can actually see. Well, it's not that easy because at the moment we do not have phase coherence in the two channels. We can take two hands of polarization, but we need to be phase coherent to really measure the Stokes parameters, because simply the intensity difference, the two channels will be different. So we really have to go to the phase.
Great, thank you.
I have a question about your LNB. If you later on, if you don't find one, unless you said it was modified, I don't know. We have folks around here that collected those things, and I might be able to find you an LNB if you post a part number later on another call or something. If you don't
I do have the part number, and I will send you the part number. I would be really happy if we had a spare one, just in case something bad happens.
May be able to help you with that.
That would be great, Bob.
All right. Any other questions for Wolfgang? All right. Did I miss anybody? All right.
Can I add something here? Because I wanted to show you guys something. Let me share.
Go ahead.
The screen. because I was looking for this is what I'm trying to do, and somebody's already done this. They've built a homemade cube 5 foot by 5 feet of 1.5 inch PVC and a tarp to enclose this Discovery dish with a normal astronomical mount, and that's totally doable. And in fact, I guess Alex Pettit already worked. They mentioned Sarah and Alex Pettit that he's already worked on this. But this is basically what I'm trying to do, but $300 mount. And they've already worked on the JavaScript for driving a different type of mount. But with an ASCII driver, I can use radio eyes. But this is doable, and this could be on rain, shine, snow, and the total cost would be about $600 for the antenna and the mount. So anyway, something to think about. I posted the article on the chat.
Great stuff.
Does the article talk about what kind of mount, part number?
Yeah, the mount.
That would be great.
Yeah, the mount is, let's see. It's a different mount, but it's basically an equatorial mount. It's a Skywatcher. Yeah, AZ GTI mount. I don't know how much that is, but it can't be $300. And I know I've used this mount before, the $300 mount. I mean, I have 3 of those, and they're super accurate for. Oh, is that it, Conrad? Okay, well, the article shows you with.
Yeah, my audio was turned off. This is what I use for outreach in normal astronomy. I've had this for several years. This did cost me $400.
Well, there you go.
And it does have Wi-Fi. I know some people have expressed concerns about that. I haven't used it for radio astronomy yet. That is in the plans, you can hook it up to an iPad or an Android device. You can't use it in Windows unless you have an emulator for Windows. It's very easy to use, but I believe this one has a limit of about maybe 10, possibly 12 pounds. And you do have to make sure that things are balanced in there. And it should work. And
yeah, the Discovery dish is only 2.2 pounds. So.
Oh, 2.2, that's a piece of cake.
That's a piece of cake. And with a tarp, a cube made out of 1.5 inch PVC and a tarp, this guy's done it in really harsh conditions. And so as a start, this is not a sophisticated radio telescope, but as a demonstrator, portable, something that is drivable within something that just about anybody can buy, I think it would be a solution, not the perfect solution. And I still have to come up with a mount or an attachment so that I can mount it. And I can do a 3D printed, I can design a 3D printed type. What is that, Ted? Is that something?
You'll need a Vixen style plate to attach to this, which you can buy very cheaply through some websites.
Well, I 3D printed a couple of Vixen mounts myself in PETG, and it works.
Okay.
I did it for a Meet C90, an old one that I needed to attach to one of these mounts, and it works great. No problems. So I can do that for this. So I just ordered it, and I'm going to, instead of talking about it, I'm going to do it. And if it works, it doesn't work. It's a good mount to have. Another one, my 4th one. So for $300, are you kidding me?
Great. Thanks, Pablo. And Andrew just popped in. Last but not least, Andrew.
Hello. Oh, you're asking me?
Yeah.
Well, I don't have anything very much to say today, and that's very unusual for me.
Okay, well, you were just last anyway, so thanks very much. All right.
Well, Andy, you got a bunch of Zooms coming up, right?
Oh, right. Yeah. So, sure. So, through the British Astronomical Association, we're doing a number of sort of ultra specialist meetings, and people be aware of the hydrogen line one and the GNU radio one. But we're now starting a very low frequency one and a muon detector one. And for anyone who's interested, tomorrow we've got the first very low frequency one or sudden disturbance one. And depending on how that sort of tester goes, we may well run others.
And you made some posts on our email reflector, the forum.
I have. What did I put them on?
Okay.
I'm always putting posts on there. I forget what I've done. What am I? Oh, the mount. You were talking about mounts there, weren't you? I'm just interested in this question of mounts, but basically because I get the mailing list from that Discovery Dish folks, and they've produced this new Discovery Drive, and I noticed that some people had put comments on saying they'd ordered that, and it looked very exciting. So I was just interested in what represented the best choice for anybody who wanted to buy a drive to run their radio dish. Now the Discovery Dish or Discovery Drive is coming in at $699, and it's listed as having a capacity of 5 kilograms that it will carry, which I think Pablo's just mentioned is easily good enough to carry the Discovery Dish itself. But of course, many of us might like to drive bigger dishes. So I posted a couple of links to alternatives that I'd found that talked about being able to carry 10 kilograms, etc. And I just wondered what other people thought. Not that I'm personally looking to buy one, but I just always interested conceptually in these things. And I know some people have got driven dishes that they can move around. So, guys, here's any particular recommendations for anybody that wants to buy something like that? Or is that Discovery Drive the best one?
The 10 kilogram drive is on AliExpress, and it is a weather solid version of the older drive, the one that uses stepping motors. I've forgotten the name of the stupid.
Do you have a link? Do you have a link to that?
I do not, no. But just go to AliExpress and start looking for drives. You'll find all kinds of stuff. And it's very interesting. Keep in mind that there's going to be a tariff, unfortunately. But yeah, I think they're asking about $300 for that one, Pablo. The drive that's on AliExpress is 300
for you. I'll find it for you now.
Oh yeah, good, Andrew. Thank you.
As I put the link on, I should be able to find it. Where are we?
Yeah, Don.
Sorry, carry on.
Don, this is Adrian. I had a question. I know you mentioned that a lot of these drives are stepper motor driven, but do they drive? Does the stepper motor then drive a screw drive?
No, it's not a worm drive. The stepper motor drives a gearbox.
Oh, okay.
With about a 40, I think it's a 40-to-1, but I can't swear to it. So they're using a NEMA 23 mount stepper motor. It's not very large, but it doesn't really have to be if it's geared down small enough.
Right.
But my aggravation with that kind of drive is, yes, well, but you count steps and use that to tell where you are.
Sure.
And I don't like it because all you have to do is have enough instantaneous load of some kind or something, skip a few steps, and Bob's your uncle. You're pointing somewhere where you don't think you are.
Oh, absolutely. That was one of my questions about all these cheap drives and what kind of resistance do they have to wind loading?
Oh, well.
And that's kind of an issue.
Well, but that is the real issue is that nobody ever specifies the torque capacity. In other words, you can take a 10 kilo load, 20 pounds roughly or more, and that's the load that it will accept. Well, that just has nothing to do with the torque that it will exert. Right. So if you can have a perfectly balanced antenna in calm weather, and it could weigh 20 pounds or 20 kilos, and it will move it. Get a little bit of wind on it, and all of a sudden you're probably exceeding the torque capacity, and you're going to start skipping steps, and you don't even know where you are.
Exactly.
So I think, and I am remiss in this, I'm kind of a jackdaw, a little bit of a, I like shiny things and go to work on them. But it seems to me that a very simple experiment would be to take a couple of these mounts and stick a yardstick on it and hang a weight on it and see what its torque capacity is. Because that's a dynamic measurement, okay? Yeah, there it is. Thank you. Thank you, Andrew. I think it's a little cheaper here in dollars, but not much.
Yeah.
Yeah.
We don't have any
Don, are you going to do that?
I'm sorry, Wendy?
Are you going to do that? I.e., hang a yardstick off the, are you going to, because obviously these people, they haven't tested it that way, right?
Right. They won't give those specs because I don't know, because it depends too on the velocity you're trying to obtain. In other words,
Andrew, can you put a link on the chat?
Yeah, I certainly can.
Thanks.
So Don, what about the manufacturer? Do you know who the manufacturer is?
Oh, heavens no, somewhere in Guangdong province, who knows? Yeah, or Shanghai, probably Guangdong province. And what they've done is they've adapted a previous drive, and I wish I could remember the name of that thing.
It's the same one without Pro on it.
Yeah.
Can I just say something?
But it's not.
From the optical telescope group, I mean, this is just a very common thing we deal with all the time. I would highly recommend that some of you people look into the mounts that are used for optical telescopes. I mean, I've got a very expensive mount that I've been using with my optical equipment, and I'm getting accuracy. I've got 20 pounds on it too within arc seconds. I mean, it's just that kind of high precision. Now, for what you guys want to do, there are certainly options out there at a much lower cost rate. The one I showed you a few minutes ago, I used that for outreach programs. It was $400. You could put up to 10, 12 pounds on it. And as long as you have it balanced, it's going to work really well. And the software is already out there, free software to make it work well. So, I mean, if you've got like a large 5-meter telescope, or a 3-meter telescope, things get a little more complicated in those areas. But for somebody with a 1-meter dish, you could easily use something in the optical astronomy category and do quite well with it.
I would like to emphasize the point about wind load. Just to give you an example, we have a 1.2 meter dish, which is on a trailer. Some of you have probably seen pictures of that. This morning, we found this has moved the trailer because of wind. It has moved the whole trailer. It's just a 1.2 meter dish. We had some fairly strong winds, and we didn't put it in stow position. And we always find that the limiting factor is torque and especially wind load. And that's different from optical telescopes. They are typically designed to carry weight, which has to be very balanced then, but they carry weight. And the radio telescopes, the limiting factor is torque. And we've always come across that. At one case, our mount on our 3-meter dish was heavily damaged through wind. It really bent a 1.5 centimeter steel rod just by wind. And to give you the extreme dish that you're seeing behind me, that's of course 25 meter, the wind load in full storm is 250 tons. So wind is really a strong factor. And I only can emphasize that.
I agree wholeheartedly.
I mean, I looked up, I mean,
This
as I
is
said, that Discovery
this
drive was $699. I was looking up at other alternatives, and the
yeah.
ISO G5500 DC came up very highly rated. And this one has, it says, the torque is listed here. We've got a braking torque of 40 kilograms meters, and I've no idea how that actually equates to the sort of level that you would need with anything up to, say, a 3 meter dish. I mean,
Well, you can imagine all you have to do is weigh it and stick it on the end of the length, and that's where you get the foot pounds. It's so many feet in pounds at that distance. Don't forget that the torque depends on the square of the radius. So the farther out there it sticks, the more torque it takes to the square of the distance from the point of the pivot rather than the distance to the pivot. So even though it's talking about foot pounds here, which is a holding thing, that's what it'll keep in the presence of a load, but it's dynamic torque. The other thing I want to show you is if we can put me on the screen, I'll show you this. This is the one that is the basis of the sealed one that Andrew just put up. It's the same structure. You can see here is the stepper motor. Here's the azimuth stepper motor. Now, here's the drive electronics are in here underneath the top. And this is the lead from the stepper motor driver to the azimuth stepper motor. Now tell me that you're driving that at 15 kilohertz with spikes on it. Tell me that's not going to get in your antenna. I don't see how you can do it. This isn't even shielded. So we need to look into this more carefully, I think. This thing was about $300. It's available on Tinde, Tinde, and it's an older design. And the chain to drive it is incredible. The guy's driving these stepper motors with this. It's hard to see it. This is the PC board right in here. These are the little drivers. It's the common ones that you use. And it's got a type C 12-volt input and a type C input to go to your USB. And I think when I get this mounted up, I'm pretty sure it's going to be noisier than living hell. But I'm not sure. I'm pretty sure about it, but not too sure. By the way, it came with a missing screw on the drive there. I've got to find a thing to put in it. It's well made. There's no question about the fact that it's well made. But now there's no way you can put a sensor on this without a lot of difficulty to give you the azimuth position. You can go over here and put one of those little magnetic drives on here to give you the elevation without too much trouble. So anyway, that's kind of where we are. And I think putting a nice plastic cover on this thing isn't going to make that much difference if you have this kind of drive to the azimuth. There's no slip rings on it. You just either wrap it up or be very careful. And you can start it. You see how easy it is to turn that motor when there's no drive to it. So you have to start this out by turning it to north. They want it to be north and vertical to start with the drive, which has a very large tool chain of 3 things that you have to do to get it to drive for our use, for astronomical use. So that's where that is.
From experience, the Discovery dishes, wind loading, it's not a problem. I've had them, I have 2 of them. One mounted on a cheap tripod with sand bags And I had winds of up to, last week, I had winds of up to 50 knots, 50 to 60 knot winds here in Southern California. And the one with the sandbags didn't even move, and it's extremely sensitive as far as the skew and the elevation because it goes to the GOES 18 weather satellite. So it did not have any problems, didn't even move. So I don't foresee a problem with the Discovery dish wind loading. I have the 2.1 meter mounted on a Chevy front axle, and that one's been there for years and no problems. I have the elevation is a linear motor, and so that's a different story. But the Discovery dish, it's not going to be a problem, the wind loading. So we'll see. I'll experiment.
Can I
I'll
show,
report back.
unless you want to hurry up and finish this, Rich, I can show one that I was talking about a second ago.
Well, I just want to, before you do that, Andrew, I've got a 5500. I've had it for 10 years. Very durable. Your only issue with that is that even though the antenna mount costs only about $400, the interface to your computer costs $600.
Oh dear.
So I actually built an Arduino interface to it, which was relatively easy, and I'm driving it with an Arduino, not the official interface to the computer. That's the expensive part of that whole thing. But the 5500 mount itself, highly durable, super. I bought it for AmpSats, and I'm going to put giant antennas on that, and it works great.
So in terms of if you've got the computer interface for that, how do you actually then drive it? In terms of your computer, do you have to write your own software for it?
There's a ham radio, HRO. There's a number of interface softwares that work. It'll work for most things, but mostly it works for the AMSAT satellite tracking. I'm found an astronomical tracking interface for it.
Do you have the SAT controller for your 5500? Because that's what I use for my 5500, and I've been in contact with those people to see if they can actually adapt it for radio astronomy.
I would love that. That's exactly what I'm missing on it.
I have it right here, and it works great. And I can track the sun with it, the moon, no problems.
Okay, put the link to that or something, or
the SAT controller. This is for AMSAT stuff.
Well, I was saying, so you can actually see the astronomical sources track it with astronomical sources.
It's specific. It has the sun and the moon for EME. The moon for EME, and then the sun. I don't know why they have it. So I use the sun to calibrate it perfectly, so it'll follow the satellites, the LEOs.
Right.
But it's hands off. It works great, and those people, I'm sure, could be prompted to adapt it to radio astronomy, and it's plug and play.
Yeah, it's a great mount.
It's csntechnologies.net. Let me write it down. And they're very responsive, but this is only for ham radio satellite work. And anybody that does satellite uses this controller, which is not really that expensive. I think it's like 129 or 100 and something, and it connects directly into the GS 5500, and it's got it does including logging. It does everything for you.
Yeah, I bought the ham radio version of that, and that was $600 at the time. But I'd love to see the cheaper one. Okay, Bob, 8 minutes.
Okay, I'm going to share my screen here. And I wanted to make a couple of comments too about what's being said. I think that on those ham radio things, all you need to do is you're using capillary and element data for tracking satellites. And if you had a capillary and element set for the astronomical thing that you want to observe, you could accomplish the same task, I believe. And I also want to mention that I don't think it's torque that's as important as inertia when you're analyzing these drive systems. You have to know that your driver can handle the weight and the load. And what Pablo is saying is correct. The little Discovery dishes are just not very heavy. And so it doesn't take a lot of effort to move those around. And the wind load is critical, though. I totally agree with what Wolfgang is saying. But again, the astronomy, the Discovery dish may be so small and pass enough wind through it that it doesn't exhibit much wind load. But if you have a larger, like maybe a 1 meter or 5 meter dish like I do, my 5 meter dish weighs over 1,000 pounds and it's solid spun aluminum. So I found these. Can you see my drawing on the screen now?
Yes, we can.
Yeah.
Okay. Well, this is just for one axis, and the other axis looks very similar. And there's a motor that will attach in this area. And these slewing drives were quoted to me at about $2,000 for two of them, so that two axes movement. And it'll handle my load. I have an Excel spreadsheet that I developed to consider wind loading and the weight of the dish and the control, the axis, the rod or the steel rod that I was going to mount it on and all of the different pieces. But if you don't have the inertia matched with the gearbox and the stepper motor that you're trying to use, it won't move the dish. It can't start the motor.
That's right. The torque and inertia are related, and the same as F equals ma is related for linear motion.
And if you try to move the dish and it's not powered up, you have to be careful there too, because you can generate DC back bias into your control system. So if you're not designed for that, you can damage your electronics. So you want to be careful. And usually what can happen too, if it's turned on and you're pushing it against the drive, you can strip the bearings in the gearbox. So that's the other thing you want to watch for. And I've done that before. So anyway, there's a company that's out there that, they're making this big, humongous drive system. And I'm sure I saw they have a catalog of different XY drivers that you can pick from. And I think if you drop down in size to something that will accommodate yours, the cost would come down appropriately. And that big one that I just showed you, there people here in this local area in North Texas Microwave Society have purchased that. And what they do is they insist on shipping it by air. And you go to the airport, DFW airport, and pick it up. And you got to have a pickup truck or something because it's going to be loaded on your truck on a pallet. And it could be that one that I just showed you is about 600 or 700 pound drive, I think. It's a honker. And I just hadn't pulled the trigger on buying it, but one of these days I may sneak it in past my wife.
There are LTAS drives that are made like that one, Bob, that are a little less expensive, around $800 or $900.
Yeah, these people sell them for less, and they have smaller ones, but that one.
The ones you look up are for solar trackers, and they'll handle a pretty good size solar cell mount. So they'll do the trick. The guy that does those is Paul Andrews.
But people around here have used prop pitch motors too in the past, but they're harder to find.
Huh?
They're harder to
I've got
find.
one if you want to pay the freight. It's about 150 pounds.
Yeah.
But it's 9,000 to 1, so you can drive it with a pretty small motor.
Yeah.
But it'll just do azimuth.
The other thing is those 5,500 drives, I don't think they have very much resolution in terms of where you're going to aim them.
No.
That one I just showed you, you can get better than a degree accuracy and resolution.
Yeah. The 5,500, I was going to ask you, Rich, where were you able to get the 5,500 without the box to drive it? Just the motor mount.
Oh, ham radio
Because
outlet.
They won't sell just the motor or just the mount. They'll sell you the whole thing, but they're running up around $800 or $900 now.
Well, some of the people, you get the little boxes that you can manually steer the dish, and then you connect this other PC board to that.
Exactly.
Is that what you're doing, Rich?
Well, I mean, the antenna mount comes with a box that actually has all of the, that drives it.
And stuff,
but
right.
the computer interface to that box is the one I was saying was very expensive.
Right.
But you have to have the driver box with the mount. That's just because that's where the cables come in from the antenna. They have to go inside your ham shack in that.
Yeah.
And then you can drive. Then you can hook like I hooked a Arduino to that. It was very simple.
Yep.
And driving that. So.
But you can't buy just the mount. That you can drive yourself, because all it is a motor and a pot, and the gearing and all that stuff, which is really the important part.
Yeah.
But you can't buy just the mount without buying the box too. And the box is a piece of it's analog masterpiece inside. It's got more op amps than I think I have in my junk drawer.
Yeah, I haven't dismantled it yet. So
it
works too well.
It works fine. Don't misunderstand. It's just that you have to have that driver box when you buy it. You can't just buy it without the driver box. And that's the part that we need to buy, is without the driver box, so we can drive it with something like an Arduino or a very simple switching driver or whatever it takes, because it's just a small motor. But it's pretty well made inside. I've had it apart. It's not too bad. And the pot doesn't have the resolution. Bob's right about that. You don't get the resolution you need for even probably if you could rig it up to I'm stammering here. Somebody has rigged that to drive the solar dish, the solar cooker dish, and has successfully driven a solar cooker dish with counterweight with that 5500. So it can be done.
Yeah, it's a very good motor. Yeah. I'm gonna turn off we're gonna close out the session. I'm gonna leave it open for the after party. You guys can chat as long as you want, but we're gonna close this out for the video. Remember, next Saturday is the Western Conference. It looks like it's only be about 4 hours, maybe 5 hours. We got a number of presentations that are going to happen. We are still looking for anybody else who wants to present. So I'm going to send out the link probably tonight, and that with the preliminary agenda, we'll send out one more next week, and then I'll see you guys all next Saturday.